Okay, so I bugged out. I tried to pause it and instead I just stopped the video, so that didn't work. But when I said, is this finished? No, because what can we do here? We can just cancel these two, right? Because remember, this is multiplying to this and this is multiplying to this, so you can cancel these. So your end result is just square root of x minus 9. So this is equal to that, okay? These two are the same thing. And the idea was, now look, here, this is a rational expression, okay? Let me check, am I going crazy? Yeah, no, it's okay. Okay, let's look at this one. Let's look at B. Here we want to rationalize the denominator, and notice that this square root of x is here, and we don't want any radical symbols in the denominator. Here, we have no radical symbols in the denominator because this is just over 1. Now here, how do we experiment with this? Like, if I were to say here, how did we knock out the radical square root of x minus 9? We multiplied it by the same thing on the denominator. And what I want you to do is, I want you to kind of fail at this because you'll learn from your mistake, is why don't you multiply this by square root of x plus 3 and square root of x plus 3, okay? Why don't you, actually you don't even need to multiply the numerator. What I want you to do is just FOIL these two. And my question to you will be, will you still get a term with a radical? Because if you do, then we failed, because we don't want any radicals. We want to somehow cancel these radicals. And go through the video, and let's say you're done, you realize that you get, what do? You get like x squared plus 6 root x plus 9, right? That's what you should have gotten. And this doesn't help us if this is in the denominator. So multiplying the top and the bottom by square root of x plus 3 will not work. What you want to do is something called a conjugate. And what this says is a conjugate, a math conjugate, is formed by changing the sign between two terms in a binomial. And this will be the magical thing. Instead of multiplying by square root of x plus 3, what I want you to do is multiply square root of x minus 3 and square root of x minus 3. And if you do that, this middle term will cancel and you won't get a square root of x. Okay, so why don't you try and do that by yourself, and your final result should be, when you rationalize this, you should get a square root of x minus 3 as your final answer, that this is equal to that. Okay. Right. Let's see. Yeah, okay, we're done with, yeah, we just finished all those questions. We finished everything here. And some things for you to consider are in your notes. You know, what does it mean to rationalize the denominator, right? You want to remove the radical from the denominator. Here, number 2, why did we want to multiply by the conjugate? And that was to cancel the middle term. Life without radicals in denominators is nice. And in these examples, what was accomplished by rationalizing the denominator? It allowed us to create an equivalent expression that is simpler. So you see here that, let's go here, when we rationalize this expression, this just became square root of x minus 9. Square root of x minus 9 is equal to x minus 9 over square root of x minus 9. And this is much easier, this is much easier to work with. And this, what did this become? This just became, this was equal to just square root of x minus 3. And why is that? This is nicer to work with. Okay, so that's the idea of this, is to, you know, work with things that are a little bit nicer. Okay, we're done with those questions. I'll make another video for 16, 17, and 18, and then we are done with this lesson.